All right, so what chapters are on this test again?
4, 5, 6, 7.
Oh, that's the whole four.
4 through 7.
4, 5, 6, 7, yes. That sounds like a lot, but most of those have only 2 sections in them, right?
Macro section.
All right. So, chapter 4 was the x, p of x stuff, remember? And then the binomial stuff. What kind of kills me is, when would I use these formulas right here that I'm writing down? When would I use them?
We have a list.
Yeah, it's kind of a giveaway. I would use these formulas when I'm given x's and p of x's. I mean, right?
Yeah.
Is the
Okay.
formula sheet right now?
Yes. That's what's happening. So this is section 4.1 and 4.2. 4.1, 4.2. Together they just make a normal problem. And then we did binomial. Does that look familiar? Okay. Then you have 2 of the best little formulas for the mean and the standard deviation yet. You guys remember what they were?
NP,
NP,
square root of NPEQ.
NPQ, kick ass. So on your formula sheet, you can't have any words, but you can like separate stuff, right? There we go. That's chapter 4. Right? I like it. Notice I did not write chapter 4, right? So no words. Chapter 5, no formulas. You're not allowed to write down any formulas. Ha ha. The thing is, on the practice test and in the homework, you had to use the formula a plus b divided by 2, right? To get the mean of a uniform, you had to use the formula square root of b minus a squared divided by 12 to get the standard deviation, right? So I want you to know those exist, but now I'm never going to ask you about them again because they're not really used that often. You guys semi with me? So you do not need to know the mean and standard deviation formulas for uniform. So why can't you put anything down? Because the only thing beyond that is the concept of how to construct it and then how to get probabilities, right? So what does a uniform curve look like? Uniform distribution.
Bow shape.
Uniform. Uniform. Yes. Big box. That's it. There's just a big box. So why do I not need formulas to help me? Because a slice of that is a rectangle, and I know areas of rectangles. I don't need any help. It's when I have curvy-sided shit that I'm like, oh, I need some help, right? And that's why we have the z-score chart. It just helps us. You guys similar with me? Yes?
Can we bring that chart into us with the test?
Oh, hell yeah, you better, right? I'm pretty sure the day I gave it to you, I said, don't write any notes on this because you're going to use it on the tests and some quizzes. You with me? Yeah. So on the day of the test, when you bring up your test, you're going to bring up your formula sheet. You're also going to bring up your z-score sheet. Let me look at it, and then I'll let you on your way. You with me?
Yeah.
Okay. How we doing so far?
Okay.
So chapter 4, nothing from chapter 5, just draw a big old rectangle and do shit, right? Chapter 6 brings back these guys. We knew this guy from before. We also knew this guy from before, right? Those are from chapter 2. The one new thing, it comes in chapter 7. So that's chapter 6. That's all chapter 6 is about. Chapter 6 is about making z-scores and looking them up, right? What about chapter 7? What happens? So this is where my first class went a little crazy. Yeah?
Over square root.
Yes, chapter 7 is the central limit theorem, CLT. I affectionately call it the chicken lettuce tomato. That is the one that says when you take a sample of greater than 30, 2 main things happen. Your distribution becomes normal enough, and the standard deviation gets smaller exactly by this. That's a sigma there. Right?
That's sigma over x?
No. What is this? Can somebody read this to me? No. No, sample standard deviation is S. Try again. This is the standard deviation of the sample means. This is a subscript, right? This is not a little formula. This is the standard deviation of the sample means. I like it. Now, I'm going to write a formula we have not seen before, but we've used it. Yes, go ahead, yes.
Is that thing a 2 next to the standard deviation?
A 2.
Mu added by 2.
Oh, no.
See?
Is that better?
Oh, yeah.
Okay. Okay, I like it. It's a very good point, though. If I were you, I would put eyes on these formulas on my worksheets and such where I used a computer to create them, so you make sure you don't make a mistake like that. You guys with me? It's on you to have the correct formula down. Okay, I like it. So, the z-score formula never changes. It's always our data point minus the middle divided by the spread, always. There's a formula we've used that I didn't want to write down because I don't want it to become confusing. I'm going to write it down now. Yes?
That last formula, just to be clear, it's from 7, right? Not 6? Chapter 7?
Totally. Yes, exactly. This is 6. So if you want to. Sure. Yeah. So, we've done this formula. If I were you, I wouldn't even write it down, to be honest. But we've done this formula last time when we got into chapter 7. Don't we sometimes divide by the new standard deviation, of course, right? That's one reason we change it, so we can get the right z-score for when I'm talking about groups of things, correct? So the z-score formula is always the same. Our data minus the middle divided by the spread. It's always that.
Just the top one is population and the bottom one is sample.
No. How do you know that's not a sample I'm talking about?
Sample mean.
That's a population mean, correct? That's a population standard deviation, correct? Okay, I want to really be careful. If I take, let's go down this road. If I take a sample of 43 things, will it be normal when I draw it?
No.
I have no idea. Okay, so let's talk about this for a minute. First off, any other suggestions for formulas? That's all I think you should have, but I'm open to suggestions.
Wasn't there something like that? It was standard deviation of like over 2 and then over 12? Or
Uniform, mean, and standard deviation, don't worry about them.
okay.
Yeah, I want you to know they exist.
Okay.
And you had to do some problems with just plug and chug stuff, but I'm not going to put one like that on the test. Okay. Now, this is not the most important thing in the universe, but it's still important. We've seen problems in the past. Watch. Okay. 1, 1, 1, 1, 1, 1, 1, 1. Don't write this down. Just 1, 1. 2, 3, 5. Okay. So say there's 43 numbers up here. You with me?
Yeah.
Would that be normal if I made a histogram out of it?
No.
Shit, no. But there's 43 of them, correct? Didn't I just say there's 43 data points?
Yeah.
Go with me for a second. I'm like, this is all we ever do, Jeff. Is go with you. An individual sample can be normal or not. I don't care how big it is. So what do we mean when we say n greater than 30 makes it normal enough? If I took every possible group of 43 and then plotted their means. So if I took this guy's mean and I plotted, and then I took another sample of 43 from the same population, plotted its mean, and continued that until I couldn't make any more groups of 43. Are you with me? I really want this to make sense. If I plotted all of those means, it would be normal enough. How do I know that? Because n is greater than 30. But if I just make 43 numbers up, it does not have to be anywhere near normal. Do you guys understand? Individual things can look whatever the hell they want to. But if I plot if I plot all averages of every sample of size greater than 30 that I can, it will become normal enough. Okay. So that's why this has a little subscript on it, because it's the standard deviation of the sample means. So watch this. Let's do a problem. Let's do an example problem from chapter 7. Let's say that I have people's ages, and the mean is 40, standard deviation is 7, and I take, well, let's do this, and I tell you that it's normal. We know it's normal. You with me? So if I pick one person, and you find the probability that their age is more than 42. This problem needs to be your bread and butter. This problem should be the one you're like, you find it and you go, I'm gonna do that shit right now because that's easy. Right? That's where you need to be. Can you draw this picture? How do you know what shape it is? Because I told you it's normal, right? I like it. So then you make a little bell curve, dude. What goes in the middle? 40. I love it. What else do you want to put on your picture? What's the data point we're interested in?
42.
42. And which way do I shape?
To the right.
To the right. And then you make a z-score, right? Go ahead. Make a z-score. I'll win. Yeah. So make a z-score be our data point that we're interested in minus the mean divided by the standard deviation. 2 divided by 7 is about 0.29. Is that cool? Or understood? Everybody with me? Anybody with me? Maybe I should say it like that. Is anybody with me?
You.
2 people. Okay, good.
6141.
Yeah, if I look that up, I know it's not going to be the answer. In fact, from the very beginning, I knew that the answer was going to be less than. The mean cuts it in, so I know my answer is going to be less than 50%. So if I look up 0.29, I get what again?
6141.
6141. So everybody double check. You never know when eyeballs get all twitchy and look at the wrong line, right? That's not the answer though, right? How do I get the answer? 1 minus. I love it. And that's why I desperately try to get you to draw the picture and draw it correctly, because it's supposed to help you. I knew from the beginning my answer can't be bigger than 50%, so I know that can't be the answer. I still get people that just put it over here and I circle this and I'm like, that's not more than half of the picture in that little tiny tail, right?
Yeah.
359?
Yeah.
Yes.
And then you don't have to split the negative when you subtract it by 1, it stays negative 0.3859.
Oh, no. Be very careful. Yeah, areas can't be negative, right? Probabilities can't be negative. So we always do 1 minus. We don't do that minus 1. Yeah, okay. So everybody with that, is that all right? So that's the kind of problem you can find and do it. Do those, because you know you can do them, just do them. So here's what a chapter 7 problem would do. It would say, all right, that's nice. But let's say we pick, what do you got, Jeff? 52 people at random. By the way, here's my point I wanted to make. Okay, Jeff. When you draw that picture, what the shit is all of it? What is that picture? What is that picture?
All the data.
All the data, okay. Be more specific. What's the data? What's the data? When we draw this picture, what's in there actually? People's age. Individual people's ages, correct? I really want you to get this. So aren't all these people have nothing to do with the question, does it? I'm like, if I pick one person, what's the probability that that person is in this area. You with me? So if I pick one person, I could pick this person who's younger than 40, correct? So what's the chances that I pick somebody in this is related to the area of that, just like the little bullseye, right? How you guys doing? So, to connect it to what I said earlier, if I pick 52 people at random, what's the very first thing I should do? And I ask the probability that the sample mean is greater than 42. So, one way I never teach is to first say what I'm about to say. But now that you've all suffered through my day and a half of crazy, weird-ass lecture about alternate universe Florida and freaky-ass numbers in a hat, here's the thing. If I take a sample and I ask a question about the sample mean, I obviously cannot use a picture that relates individuals to each other. I need a picture that relates groups with each other. So here's the idea. The picture I draw for this one is going to be all the groups of size 52. And now I'm curious, my group, the group I pick, what's the probability that they happen to be above 42? So this picture is comprised of all the groups of size 52. So it makes complete sense that I cannot use this here, because this tells me how spread out individuals are. I need to know how spread out groups are. That's it. That's it. So you guys draw this picture beautifully automatically, but I need to make you slow down and realize what the hell you just drew. You just drew everybody. Everybody's in here. Every individual person is in here, and you're curious that one person I pick, what's the chances they're there? Well, if I look it up, I get that's the area. So that's the probability I get somebody there, right? Now I'm talking about a group of 52 people. So of course I got to talk about them compared to all other groups. And if I take a group of 52 people, is it more likely their average age is close to the real average or really far away? If I took one person from Grossmont randomly right now and their age is 78, you might go, okay, it's a little old, okay, right? If I took a group of 80 people randomly and their average age was 78, think about that. Would that freak you out? That'd be a lot of old people, right? Now, I'm not saying that that's impossible. I am saying that's incredibly unlikely. So every sample should show up closer to the actual average. So what happens to the picture is this. The standard deviation gets smaller because my sample should be closer to the real mean, which is why the standard deviation gets smaller. So bottom line is, the standard deviation that I'm normally given is for individuals. That's why I can do this question without doing shit. I can just use the number they gave me because I am talking about one person, and that's individuals. When they take samples, oh shit, now I need the picture that has groups. So of course I can't use this. This works for individuals. I need to know how spread out groups are. So right now I need to do this. What would I do to figure out the new standard deviation? Take the old one, divide it by square root of, be specific, 52. And that's going to be like 0.983. I'm just making shit up.
972.
It's not bad. Okay. 970?
7.
970? 977?
9707.
9707. So 971?
Yeah, 972.
It's like an Abbott Costello thing. I don't know. Third base. Some of you guys got that. Okay. What the hell did I just find? What is that? Is that a z-score I just found?
No. It's your new
So here's a big thing people do. They'll do this. That looks very silly. All I did was took away that sigma x bar. But then they'll do this and they'll go, oh, 0.97, let me look that up on the z-score chart. Do you understand what I'm saying? You calculate a number, but you've lost connection with what the hell that number is, right? That's not a z-score yet, because that's the sigma, that's not a z-score yet. All right, now, I really want to make sure you understand. Were you all decently good with this first problem? This first problem should have been relatively easy.
Yeah.
The only difference on the second problem is right here. This little piece is the only difference. I'm gonna go make a z-score now, but when I go make a z-score, what do I divide by?
0.5.
The correct spread, yeah. I'm gonna divide by the correct spread. That's all that formula there says. When you have sample means, you better divide by the standard deviation of the sample means. That's why you don't really need this formula, because that captures the idea, yeah.
What if the 42 changed to detail?
So what now?
42 changed to detail? Or does this?
Why? What is 52?
52 is F.
N. And what's the question asking me?
Oh.
So the only thing 52 does in this case is it changes the standard deviation. The question is still 42, right?
Yeah.
Okay. So now I'm gonna divide by 0.971. Where was it? Yeah, so it's roughly 7. I'm gonna say that's gonna be 2.13. Damn it, I went the wrong way, okay. I can get kinda close. And then I can do what?
Look at the chart.
Look up the 2.05, get the area below. So I want this to make sense. This answer is gonna be much smaller than the first answer was, right? What do you guys get when you look up 2.05? I think you get,
9803.
what is it?
9803.
9803? Okay. So then the answer would be
0.0197.
0.0197. I love it. Isn't that much smaller than this? Even though the questions look like they're the same? But again, this is the probability an individual is older than 42 versus a group is older than 42. If I take any group of size 52, wouldn't you think that their average should be close to the real average? It should be less likely that they're gonna be way older than the actual average. Joey, I think, yeah.
Yeah, so I left the, what is that called? I forgot what it is.
You left the what now?
Oh,
Sorry.
oh, yeah. I left the standard deviation as 0.9707 and I
Sure.
left 2.06 rather than 2.
Beautiful, I love it. So when I grade these, I'm open to different z-scores based on how much you routed. Yeah, okay. So again, I want to kind of reiterate this. I haven't had this happen for a little while, which is great. But for a while, I had people saying, you know, my last stats class, they let me just do the stuff, and I'm like, I don't give a shit. You don't have that last teacher, you have me. So if we use technology, our answers would be perfect. And I don't care. Our answers are not life and death for anything. Once you graduate and you start building bridges or whatever, I know building bridges is always the freaking thing that math people go to. Then I want you to get it exactly right, right? You know, it's close enough. Just crumble, right? You guys kind of with me? So I use rounding and I use these tables because it gets the idea in your head better than pushing buttons and getting numbers on a screen. So I'm okay with the fact that our answers are going to be off a little bit. I don't care. I'm sorry. Who did I?
I was just gonna ask if we're gonna work on the practice test.
Well, yeah, of course. Yeah.
Can you remind me when we use the negative, the 1 minus
Oh,
on the bill?
so guys, what does the chart always give us? Areas that are where? Below whatever z-score we looked up. So if the question says, I want to know the probability less than something, I'm not going to have to do 1 minus at all because it's going to agree. Both of these questions were greater than. So when we looked up a z-score, we got the area below, like it does. That's all the chart can do. So we had to do 1 minus to get the right answer.
Okay.
That's why when you draw the picture, if you shade it in, you know if you're done or not. So the minute you guys use the z-score chart, you write the number you find below what you just looked up, because that's what the chart tells you. And then you step back and go, have I answered the question yet? So normally the people that do not draw this picture are the ones that just sort of circle this, because they don't even realize that ain't it, because they haven't given themselves a visual. Okay, maybe, yes.
I was like wondering when asked for percentile, like how do you?
Okay, cool. By the way, John, just to let you know, we're not going to go 1, 2, 3, 4 in the practice test because the answer key's up on Canvas. but we can totally go over some problems from it. So I just go, whatever question somebody asks, we go there. So it's wide open, right? Okay, so using the same, let's go back to this guy. Say I want to know so this is part C. What's P85? Right, I want to know what P85 is. Right? 85th percentile. Can you draw what that would look like?
Up to 85%.
So can you draw it? Can you draw it?
Yeah.
Eventually, but first draw it. So I have a normal curve still, right? I've erased that part, but it's still normal. Where would the 85th percentile be?
Yeah, right.
How do you know? So the mean is always going to be the what percentile in a normal curve?
80.
50th percentile, yes? The mean cuts it in half, so it's always the 50th. So if this is the 50th, the 85th must be up here somewhere, so there's 85% below it. Now real quick, doesn't 0.85 look like a z-score? By the way, this is a mistake, don't write this. Z-scores go down here, areas go up here. So I'm not gonna look 0.85. No, because it's not a z-score, correct? That's an area. So can you get the z-score for this?
Just look at whatever's closest to 25.
Yeah, so now you're looking in the body because that's where areas are, and you're trying to get as close as you can to 0.85.
1.04.
What? 1.04? Okay. They said 1.804. It's like, what the hell? 1.04? Does that sound right? I'm crowdsourcing this, by the way, so apparently that's good. Okay. Now that can't be the 85th percentile age, because I don't think somebody who's 1.04 years old is in the 85th percentile of ages. Do you guys agree with me? That's a z-score. How do I convert it back into a raw score until an age?
Z-score times division.
I use the reverse formula, right? So I really want this to make sense. The problems we just did, I gave you a raw score. For the first problem we did, I gave you a raw score of 42. You changed it into a z-score through the formula, and then we looked it up in the chart to get the percentage. This problem, I start with the percentage, you look it up in the chart to get the z-score, and then I convert that back using the inverse formula, right? So this formula here takes a raw score and changes it into a z-score. This formula does the opposite. Sorry, what's up?
I was confused how, like, I was paying attention when we got 1.04.
Oh, all right, so look up 0.85 in the body of the z-score chart. And what's the closest you can get?
Actual area of 0.8508.
So we're finding P85. Going to this chart and find the number closest to 0.85.
What you got for me? Oh, cool. So the closest, 8.5.
So wait.
Oh, wait, yeah. Because the next best candidate would be 8485, but that's 8508 is closer. You with me? Some of you guys aren't with me. I can tell by the look right here. You look at me with a sense of urgency and confusion and, dear God, makes sense, Jeff. Can anybody? So, when I look up a z-score, what do I get? If I look up a z-score of 0.32, what does that number mean?
The area.
The area below that, okay. If I look up an area, because I know the area up there, 0.85, right? If I look up that area, it's going to tell me what z-score that is. So basically I'm asking, how far up do I have to go? So I've got 85% below me. So if I stay at the mean, I've got 50% below me, correct? As I move up, more and more stuff is below me, correct? In fact, if you follow from the beginning, at the mean, there's 50%. The mean is 0 z-score, right? And as I move, I start collecting more and more, of course, right? So the question is, how far do I have to move until I get 85%? So if I find where 85 is, and the closer we get is 8508, I have to move 1.04 standard deviations up. Let me stop there for a minute. Yes?
If we were to put like the, so you know how there's two, how one of them says, wait, I lost the space. Okay, so you know how one of them is 84, 85, and then 8508? If we were to put like the other one, would we get it wrong on the test?
Totally. How far is that from 85? 15. You see that? How far is this from 85? 8. Closest. Yeah. Is that cool? Okay. You wouldn't like lose a ton of points, right? I'm not a Scantron math teacher. If I was a Scantron math teacher, you just lose all the freaking points. By the way, real quick, any math teacher who uses Scantron is not a math teacher. I don't know what they are. They are not a math teacher. Because what's the most important thing in mathematics? The work is the most important thing in mathematics. As you're learning it, the work is the most important. When you go out and do shit, the answer is the most important. And that's why we have software and all this kind of crap when you go out in the real world. Okay. Sorry. I don't know, I just feel like ranting today. I'm really sorry. Is all that okay? You guys okay with that? I really want it to make sense that if I give you, like the first problem we did, I gave you an X. We changed it to a Z, and then we looked the Z-score to get an area. If I give you the percentage, we just do all that in reverse. I look up the area and I go backwards, I get a Z-score, and then I use the backwards formula to get back to a raw score. So what would this become then? The mean plus 1.04, bless you, 7s, right? Why does it make sense? Because what's a Z-score of 1.04 mean?
That number is 1.04 from the mean.
1.04 what's? Miles? Standard deviations, 11. So if I wanted to get to a number that was 1.04 standard deviations above the mean, wouldn't I just take the mean and add 1.04 standard deviations to get there? Isn't that what the freaking formula says to do? Start the mean and go, 1.04 these. I don't know if you guys remember, but this is basically a sentence that defines Z-score for you. The Z-score is the number of standard deviations from the mean to the data point, right? Okay. Yeah. Sure. Sounds good. Ouch.
It's because I'm multiplying this.
I don't like projectors. Keep working them, please. Thank you. All right. Any follow-ups to that? Because what we just did was chapter 6 and 7, fundamentally. Chapter 6 was part A. Chapter 7 was part B. This is another example of chapter 6 because, again, chapter 6 is all about taking individuals, right? Chapter 7 is all about change the standard deviation because they got groups, right? Maybe. Yeah.
And all that changes when you extract the sample size is the standard deviation.
When I take samples of some size, standard deviation changes. Yeah.
Okay.
The mean stays the same,
Mm-hmm.
right?
The whole concept of getting P85 and P90, it's all the same. It's just a standard deviation and changes by the square root of it.
Yeah, it's just that formula there. Once you get the Z-score, you can just use that formula. Okay, maybe. So what about this problem? Sorry, did something? If you have a specific question, let me know. And if there's no questions, I'm gonna just do shit. Yes.
Number 4 off the practice test?
Anybody need a copy of the practice test, by the way? Hopefully not more than 2. Oh shit. Can you guys share that one for now? It's up on the canvas too. Listen to me. On the internet, on the canvas. Internet's a series of tubes. Alright. Do me a favor, what was the question again?
Number 4 on the practice
4,
test?
practice test, which I have no longer got any for myself. What's it say?
We have a uniform probability defined for 2,
Okay, cool. Gotcha. That was from 2 to 8, right?
You wanna just look at mine? I'm gonna put it on my piece of paper anyway.
I remember this. From 2 to 8. So the very first question is about.
Draw the picture indicating the height.
Yeah. If you haven't done this yet, do it. Draw the picture, indicate the height, don't say anything.
Is that a
Say again? Oh, it's okay. So like you guys told me before, it's just a big box. Big old box. What's in the box? And then how? Sorry.
1-8.
Yeah. Why? What about that? What about if I put that? Is that all right? You understand why somebody would put that? Because they just looked at this number. But you gotta put something that makes the area 1. This is 6 across, so this is gotta be 1/6 tall, so the area is 1. I like it. I like it a lot. All right, and then the next question is like 4.4 to 4.7 or something, right?
Yeah.
So not the numbers you wish you had, but who cares? A basic uniform distribution problem cannot be difficult. It cannot be difficult. It cannot be. So 4.4 to 4.7. There's the slice, and now I just gotta find the area, right? So how wide is that section? 0.3. The area is width times height. What's the height? 1/6 for everything. 3/6 is 0.5, 0.36 is 0.05.
How did you get 0.3?
How wide is it?
Ah, I see.
Yeah.
Thank you.
Again, it's almost too nice, and it's exactly the same for uniform curves. It's exactly the same, except those slices have very strange shapes, yes? Not this part. This part's nice, this part's nice, this part's nice, and then, oh shit, what the hell? So that's why we need help from the z-score chart, right? But for uniform distributions, they kick ass.
And then the last one says probability of x equals 5.
Yeah, okay. Yeah. Because if I draw 5 in here, my scale sucks, but too bad for me. If I draw 5 in here, what's the area of the line I just drew? How wide is it? 0. And I like somebody put iota on the homework problem, like a little tear came. We did talk about that a little bit. You don't have to worry about it. It's just 0. It's 0. It's fine. Iota is the right answer. But 0 is worth. 0 is fine. Is that all right? So it's all about the area. So whatever the area is. Now the rest of the problem is more interesting. Yeah,
Are you gonna continue on forward, or?
I could. You want me to?
The mean
Okay.
distribution.
So part D says what?
The mean and standard deviation.
Yeah. So look at me doing this shit. There's a specific reason. There's a problem in the homework that's just like this. And what do I mean by that? It has nothing to do with these numbers or anything, but it's a uniform distribution, and then they take a sample of size 43, I think it is. That's a song one. Sample of songs and the song length. So I like to look around and see who's done the homework, because I don't see any flashes of recognition. Okay. What's the formula for the mean of a uniform distribution again? Yeah, it'll be A plus B over 2. So the mean is 5, it makes sense, 5 is right in the middle. Since it's evenly distributed, the mean is just the number in the middle, because that'll cut it perfectly in half, right? Who remembers this standard deviation formula? You don't have to know it, but yeah, B minus A squared over 12. A minus 2 is 6 squared is 36 divided by 12 is 3. Square root of 3 is I don't remember.
Why is it 12 though? Where did that come from?
Nobody's emailed me to remind me to do this. Nobody.
Oh, that's
So I told you I would put the proof up. It involves calculus. So if you remind me, I'll throw it up there. And if you don't want to look at it, just don't click on it.
Can we have that one on our format sheet? Or
We don't
need it?
I'm not gonna ask you a question like this on the test yet. So then a really good question right now would be, okay, Jeff, why did you put it on the practice test then? Bucko, or whatever you want to put there, right? We're not in the 1950s, so probably not Bucko. Because I got a point to this, right? What is square root of 3 real quick?
1.7321.
1.732?
Another stupid question. What are the 2 on the bottom of the 2 plus 8 over 2?
How do I find the average of any, the middle of any two
Oh,
numbers, I
word.
take the average.
Alright.
Yeah. Any two numbers in the universe, if you want to know what's right in the middle of them, you average, right? I like to just put in the universe at the end of something because it makes it sound more interesting. But all right, now that's the mean and the standard deviation of the distribution as it was given to me, right? What's the last part say? What does mine say?
For
Sweet.
sample 43.
Say again.
Find a sample of size 43.
Size 43. We take a sample of size 43. What immediately happens? 2 things. Taking a sample of size 43, and I'm asking a question about the sample mean, correct? Because now I want to know the probability that this is true, right? Did I take a sample? Yes. Did I ask about the sample mean? Yes. So what has to happen? Good. What I call the new standard deviation. It's really the standard deviation of the sampling distribution, but screw that, just the new standard deviation, right? I can't use this one because that's for individuals. I need the one that works for group 43. So what else happens though?
The standard deviation.
43? Yeah. Was it 43? Did I just make that shit up? Was it? 43? Okay, thank you. Oh, yeah, sorry. That's trying to tell me the answer. I'm sorry. What is it? 0.26? Exactly? Neither. Okay. Let me stop for a minute. Do you guys see what just happened? Normally, in a chapter 7 problem, they'll just give me a standard deviation. So what do we do with it when I take a sample and ask about the mean? I change it. Did they just give me the standard deviation of this? No, I had to calculate it. But don't I have it now? And that's for individuals in this distribution. Now I've taken a sample of 43. The standard deviation changes. What else happens? What's 43 bigger than? Is bigger than 30, which means the distribution is now normal enough. Let me slow down for a minute. I'm not working with this anymore because when we plot all the averages of size 43 samples, they're going to become normal enough. Now, Malad, I'm sorry, you were telling me the rest of this?
4-1.
Okay. So what's my picture look like now? Looks normal. What goes in the middle? The mean, which is? No. What was the mean? 5. So what is it now? Still 5. So there's an average age in here. If I take individuals, I get it. If I take groups of size 2, I don't suddenly make you all older when I do that. It's still the same average. So the average does not change. Here's 4.4. Here's 4.7. I want this area. Can I do it as easily as we did over here? This is a rectangle. Area is an easy formula, right? No, I can't do it as easy, but it's not that terrible. What do I do with each of these now? No.
Turn them into Z.
Turn each one into a z-score, look up each area, subtract the areas, right? So why did part E suddenly become a chapter 6 problem? It's actually a chapter 7 problem. Because I took samples of 43, now it became normal enough. It's no longer uniform, now it's normal. That sheet I gave you guys, one of you guys is looking at it, it's awesome, with the blue and the yellow. Remember that? Yeah. The sheet with the blue and the yellow. It started off uniform, and then we took samples of size 2, and it was immediately much more normal, correct? So if I take samples of size 43, that shit's gonna be crazy ass normal. It's gonna be beautifully normal, right? Okay, maybe. So there's at least one homework problem like that, where they give you a uniform curve, but they take a sample. I'm pretty sure it's a sample of 43 songs. So it becomes a normal problem. Yeah.
But the answer, we just stop at point two.
I don't know. What's up? No. What is this? What is this? Standard deviation. So now when I make z-scores, I have to use that. Yeah, I'm nowhere near the answer, but part of me doesn't care because, I mean, one thing, it's on the answer key. No matter how you calculated the original standard deviation, if I take samples more than 30 from that original population, the averages become normal. I don't care what it looked like to begin with. I don't care. If I take more than samples more than 30, they will all become normally distributed. And then I have to use the z-score chart to find areas. I can't, it's not normal, it's not uniform anymore, it's not straight across anymore, it's humpy. It's got curves to it.
When you find both of the areas, then you
Subtract.
subtract.
Yes. So I think most of you guys got that idea. It's a very beautifully physical idea. If I look up this area, it's too much. So I got to subtract this much area off, and I'm left with the area in the middle. Yeah. Okay, maybe. I sense a drop in the mood. I sense a disturbance in the force. Now again, you're not going to see this exact kind of problem on the test. But I just wanted to give a problem like this because there's at least one in the homework, right? What you will see on the test is a problem like number 5 on the practice test. For sure. Number 5 is a more standard central limit theorem problem. Huh? No. Yes, I'm sorry, yes. Sure.
I was trying to see if we can go over number 1.
Number 1, okay. So, let's do this. Let's look at number 1. Then I'll give you guys the answer key. Right? And just to remind you guys, we've only had one test. So just to remind you guys, when you get the answer key, if you haven't done the practice test, don't even look at the answer key. You will do this. Oh yeah, I would have done that, right? You would build up this false confidence, right? So as a young teacher, my first class, I'll never forget, I gave the answer key out. This guy took the test, he got a D, and he's like, Mr. Waller, he's like, I did every problem on the practice test like 8 times, and I knew it. And I'm like, you knew that problem. I was not going to ask you that problem. I'm going to ask you a problem like that. Does that make sense? So number 1, don't look at the answer key unless you try the problems. And number 2, don't try the problems more than twice. Because at that point, you're getting to know that problem. You're not getting to know that kind of problem. Does that make sense? Because I ain't going to give you those same problems, right? Some of my colleagues do that. Some of my colleagues, you know who you are, the test is the same as a practice test, and I am sorry, but that is complete bullshit. I'm sorry, right? So if you wanted that, you chose for it. So let's do a problem like number 1. I'll give you the answer key, and then I'll see if there's questions on number 5. Number 1, let's do it up here. Because number 1 is the one you have to pretty much, I would highly recommend you use the calculator for. Oh, let's do this. Oh shit. So somebody is going to need to help me out because I've given all my practice tests away. So hold on.
You want it?
Yeah, maybe somebody closer to me can.
Hello?
Or somebody could just read it off for me.
Which number?
Number 1.
I'm here.
Oh, thank you. Let's see. Oh shit, already made a mistake.
It's a list.
-1. very quickly, can anybody tell me the probability x is greater than 2? What's the only thing that greater than 2 leaves out? -1. So what's probably x is -1? 251. So the opposite of that is 749. Right? Now you get the same answer if you add up the other ones, but it's just a shortcut to do 1 minus what it leaves out, and that's the whole 1 minus thing we've been talking about, right? But I don't care if you add up the other ones, you still get 0.749. Why is this a valid probability distribution?
Because all the p of x values add up to 1, and all the values are between 0 and 1.
Kick ass. So remember, who remembers, there's 2 things you know ahead of time that's going to happen on this next test. And let me say this. I'm not just going to ask you what does z-score tell you. I'm going to ask you this. Not exactly this number, but what would a z-score of -1.38 tell you about a data point? -1.38 z-score.
To the left
Be much more specific.
of the mean.
It's 1 point, whatever the number was below the mean.
So -1.38 z-score. It's 1.38 standard deviations below the mean. There you go. You guys with me?
Yeah.
Okay. So, first couple questions are just verify it's valid, and I think part C is what's probably x is greater to. Now, for some reason, I made part B, the mean and the standard deviation. What formulas am I going to use?
Part B was the probability that it was greater than 2.
Oh, really? Okay. Oh, good. I changed it around. Good. How am I going to find the mean? What formula do I want to use? Yeah, this drives me a little crazy. The problem has got x's and p of x's. So of course I want to use the formula that's got x's and p of x's in it, correct? So I always get somebody try to do the binomial. I get people try to do normal curves on this thing. I don't know if this is normal, right? Okay, maybe. So what do I have to construct then to figure out the mean? I got to construct a column
X, P of X.
that's x p of x's, so then I can add them up. Yes. Yes.
The way you sometimes list the last column is like x squared p of x minus m squared. Could we do parentheses x minus m squared p of x?
I never do a column of x squared p of x minus the mean squared, ever. So,
What's the last column on the table? It's x squared p of x.
guys, the formula for the variance is this here. It's over there too. I'm subtracting the mean squared from the sum of these things. So don't I need these things so I can add them up? So the fourth column should be x squared p of x. So then I can add them up, and then whatever number that is, I can subtract the mean squared. Is that cool?
Wait, so that's in the first column?
So I've got x p of x. I need a column of x p of x because the mean is sum of x p of x. So I can't add up the x p of x's until I got a bunch of x p of x's. Does that make sense? And I can't add up a bunch of x squared p of x's until I get a bunch of x squared p of x's. I have no idea when I say that how it sounds to you. Does everything I said just now make any sense? Sometimes I get people looking at me like, sounds like you want to be speaking English. So this last one I want it to be this. Now if this is list 1 and this is list 2, how do I make list 3?
Times it.
L1 times L2, right? So if I just go to L3 and make it L1, so second one, L1 times second 2, L2. Right? Now, here's something I want to point out. So I always do L1 times L3 because x times x p of x is x squared p of x, correct? Now watch this. If I do L1 squared, isn't that x squared? Times L2, that's x squared p of x, right? Jeff, you said L2. Now watch how the numbers are not gonna change at all. See them? See the numbers? Exactly the same, right? Because both of those are the same damn thing. So I always do L1 times L3. Why do I do that? One less key to hit. I don't have to hit the squared button. You guys understand? In fact, that explains a lot of mathematics. We want to do shorthand because math people, we don't like wasting time. We want to just get to the point.
Wait, so it's just L1 times L2?
L1 times L3, that's what L4 is going to be, yeah. So now, these are my XP of X's. If I add them up, I'm going to get what?
The sum.
Sure, but what will it represent? What is the sum of XP of X's?
X squared. F of X.
Right? The sum of the XP of X's is the mean. Again, we're past the point where I showed you the mathematics about why that formula makes sense. Do you guys remember? How do you just find the mean? Don't I just add them up and divide by how many there are? Right? So isn't the mean formula sum of x divided by n? Right? What's on the bottom of any probability? What's on the bottom of any probability? The total number. So isn't there over n built in? It's the same dumb formula. It's just, that is a better organization of the formula, given that I got a bunch of x's and p of x's. It's a shortcut, because I gave you the data in a different format. You guys? Okay. You lost me at hello. Okay. All right. So if I add this column up, I'm gonna get the mean, because the mean is the sum of the xp of x's, and that's what these are. If I add this column up, do I get anything that means shit? No. If I add this column up, that number goes here, because that's the sum of the x squared p of x's, right? So then I have more work to do. So how do I get the sum of L3, for example?
List now.
Yeah, hit second mode to quit. Right, get out of there. Then hit second stat to do something. I want to do something to a list. I want to do math to a list. I want to sum up a list. I want to sum up list 3. I also want to sum up list 4, right? So if I just hit second enter, I can go back and replace that with a 4.
We can just also do one more stats.
Total. 2 var stats. I would do 2 var stats on L3 and L4 at the same time, and then just pick out the appropriate sums. Ooh. The reason I don't just show that is because you get all this other shit that doesn't mean a damn thing, right? And that just confuses people when you see too much shit. Yes?
How'd you do the sum command?
Go to, see above stat, it says list. So hit second stat. I want to do math on a list, right? See the math?
Gotcha.
And I want to do sum. Kicking the ass in. So, what's the mean of this problem? What's the mean of this distribution?
4.253.
4.253. How do I get the standard deviation? This variance would be this minus this squared. That's the variance, and then take a square root to get the standard deviation. Yeah. Baby. Okay. A little dilly-dilly. Just because. All right. Is that okay? Again, the answer key is up on Canvas, right? So I've got all the work from that problem up there. So somebody had a question about, oh yeah, I said I would give the answer key out. I don't have them. They're up on Canvas. So you want to look at number 5? Was that the question? Oh, okay. So what's number 5 say? It's got so much trash, right?
Yeah.
the mean?
120.
Sorry? Do it again, sir.
Yes.
And then what was the standard deviation?
34.48.
And do I say this?
No, 48. 48.
34.40?
Yes.
40.
Did I say it was normal?
Yes.
Okay.
Camera's facing the corner.
Camera. I need a little AI pod that'll just follow me around. Okay. And then part A says the probability greater than 302, is that right?
Yeah.
So this is the problem. If I were you, you should be at a stage where you would seek this problem out, do it, because it's the easy bread and butter problem. Make a Z-score, look it up, make sure you get the right side, right? That should be your bread and butter. You don't want to leave that one undone because that should be a relatively easy problem. So, if you draw this, what goes in the middle?
21.2
Yeah. Where's 302 go?
to the right,
To the right. And where do you shade?
to the left.
Above. I love it. That points you in the direction you want to shade. Go ahead and make the appropriate Z-score, don't say anything. So you have to create the Z-score first, right? Who is it?
15742.
Now, if you do, let me show you a problem. Let's say somebody does that work. I will very often get somebody say, okay, 57.42%, circle that shit and go on. Is that right?
No.
What is it that we just calculated? Z-score.
Z-score.
How many places should a Z-score go to for us? Because you got the weird ass teacher that wants you to use paper when they've invented calculators, right? So whenever you're about to calculate something, make sure you know what it is you're calculating. Especially Z-scores versus percentages. They look like each other. That looks like 57%. But it isn't. It means that I'm about a little more than half a step up. That's what that means, correct?
It's not 57.
I don't know, I'm just crowdsourcing. What happened?
It's .6032.
6,
0.
0, okay. Oh, did you look up 0.60? Oh, all right.
0.7357.
Okay, so we got a Z-score 0.60, that means I'm 0.6 of a step up from the mean. If I look up 0.60, I get what was it,
357.
357?
U.
And is that the answer?
No.
No. And then how do I know it's not the answer? Because I was nice to myself and I drew a picture that I showed, hey, the answer's on that side, right? Yeah, so they point 1643, 2643, that's better. Okay, what does that mean? What does that number mean?
Percent of the data is above 302.
Be more specific. Be more specific. Don't say of the data. Tell me what does it mean? What's the question? The probability that, be very specific, what's the question? Yeah, the probability that a house I pick makes more than 302 pounds of trash. So one way to interpret this is, there's a 26.43% chance that a house will generate more than 302 pounds of trash a week, right? You guys with me? Because I don't know, it's possible that somebody who's gonna give you a test soon is gonna put a question just like that on it. That's possible. I don't know. Another way to say this is 26.43% of homes generate more than 302 pounds of trash a week. That's equivalent to what I said earlier. Either way. You guys with me? Now, the next question and the question after that are just like this. The next question, I just have to make 2 z-scores, correct? Look up the areas, subtract the areas. We did a problem like that earlier. What's more interesting to me is, wasn't this part A number 1 or something?
Yeah.
All right, so doing my test are like doing freaking legal documents. Part B, what's that say? What?
The probability that a house generates between 274 pounds.
So let me ask this again. Part B. Part B.
Oh.
Okay. Part B.
If 120 houses are randomly selected, how many would we expect to generate a mean weight greater than 302?
Does 302 sound familiar?
Yeah.
Yeah, so it's gotta, so again, what was one way to interpret this? 26.43% of houses generate more than 302 pounds of trash, right? 26.43% of houses make more than 302 pounds. So if I pick 120 houses, can you predict how many will generate more than 302 pounds? What did we just say? What percentage of houses do that? 26.43% of houses do that. And we pick 120 houses. So how many should generate more than 302 pounds of trash? 26.43% of 120. This is the percentage of houses that are above 302. I specifically say, if I take 120, how many of them? Well, that percentage of 120. So I like that kind of problem just to show you, really make sure you understand what that number means once you get it. That is a percentage of total houses that do this. So if I give you 120, well then you're like, okay, I'll take that percentage of a 120, because that's the percentage of any number of houses that would do that. That's what I would predict. And whatever the hell that is, I don't know.
0.0385.
No, that's way too small. Wait.
31.716. About 31 houses.
So about 32 houses or something? You just round it, so you round it up in this case, yeah. This is 31.7, right? Okay. You look at me like, I don't know with you, man. We go up, we go down, I have no idea. This is a problem where you just round it to the nearest whole number, because the answer's gotta be a whole number, right? Yeah. Okay. Yes. Now those, yeah.
2 on number 5.
Yeah, so let's keep going. Well, I'm sorry. A2?
No, yeah, A2.
A2. So A2 is just like this one, except you have to make 2 z-scores instead of 1, right? So are we cool with that? Once you do one of these, they're all the same. If I have 2, I make 2 z-scores, I look up 2 areas, I subtract the areas, and done. Next, yeah. If I want it greater than, you gotta do 1 minus. If I say less than, this is exactly what the chart tells me. I don't have to do 1 minus. Yeah.
On the test, is there gonna be more space to like draw stuff?
Maybe. Sorry. We'll see. Sometimes, I don't know. I haven't been doing this semester. Sometimes I put everything on one side of a piece of paper and say, use your own paper. But we'll see. We'll see how I'm feeling. And if there's not enough room, just use another sheet of paper. Yeah.
So for 5, A3, it's asking for the probability of x less than 100, but then when you get the z-score, it comes out to like negative 5.25.
Sweet.
So basically it'd be 0, right?
Yeah.
I love it. So what's your chart say? So in part A3, right?
Yeah.
Was x less than 100?
Yeah.
Yeah, so when you generate, everybody really quickly make 100 into a z-score. You basically just told the answer, but let's all double check. If I do this, what do I get? Negative 5.26, okay. Real quick, where does unusual start? 2 standard deviations away, correct? This is 2.5 times further down than the minimum usual amount, yes? That is basically 0% that it's going to be less than that. I've gone so far down on the normal curve that I've left out so little below me that it's basically zero. The chart, what's the chart say?
1,001.
Say again?
1,001.
Yes, the chart, if you look it up, it gives up. The chart gives up at negative 3.5. Do you guys see that? Negative 3.5, it goes 0.0001. That's at negative 3.5. If I go further, aren't I getting smaller and smaller? So once you're past 3.5, so basically what I say is if it's off the chart, it's either 0% or 100%. If I would have said greater than, do you guys see how it would have been roughly 100? So I would say like this, my answer here would be that. Do you see how the answer is not 0? The answer is approximately 0, right? Most humans, if we saw 0.0000000000002, we'd say that's 0. You with me? Okay.
Why did you put 302 instead of the 281?
I don't know why, because I was looking over there. I don't know what I did. Yeah, it should be 281.2.
Okay.
I was just trying to skip ahead to the idea. Thank you, though.
I'm confused.
You guys with me?
Yeah.
Yes?
How'd you get the 20% again?
20%. Where's 20%?
There.
Oh! Approximately. Oh, yeah, I'm sorry. Yeah, that's my fault, Yeah, if you wanted a teacher, you could read the writing, you chose poorly. I really am sorry. I just suck at it. I don't have the patience for it. So, oh well. I did tell you the story about the one teacher that we said, what did you write up there? And he said, somebody remember, I can't read. Somebody remember what I wrote? I'm like, no, no, retire. Just go away. So the minute I'm like, I can't read that, I'm out. I'm like, I'm gone. It's enough for me. I don't want to put people through this. Thank God it's not yet, because I'm not ready to retire yet. Okay, maybe? No? Okay. Is that all right?
Yeah.
And then what happens in part C?
What is the lowest rate that would place a house in the top 5%?
Can you draw the top 5%? What would that look like?
Really close to right.
E95.
Yeah, top 5% would be here. So I want to find the z-score so I can do everything backwards. I'm given an area, so I want to find a z-score, and then I can convert it back to an x, right? What's wrong with looking at 0.05 to get the z-score? The chart only understands areas that are below. So the same z-score has 5% above it. It also has, there we go. We finally caught up to Charlton. So that's the 95th percentile. Take a minute, don't say anything. Look up the z-score for 0.95 area. Now please watch this. You're not looking 0.95, because 0.95 is not a z-score, correct? Bless you. You with me? It's not a z-score, it's an area. It's going to be one of the interesting ones. It should be an asterisk.
Yeah, it's
1.605.
You guys see that? The closer you get to 0.95 is 9495 and 9505. Do you guys see that?
Mm-hmm.
So that's the asterisk. Why do they put asterisks in some places? Because that is a very important z-score. We're going to see that a lot. And yes, those exist. Very important z-scores. Vizs. VIZs. Okay. And now how to make that into I forgot the pounds of trash. So mean, what am I saying? Mean, I said mean and mu. So I said mu. Just throw stuff in there, right?
Yeah.
Okay. Now what about part D? That's where we have to do what? Get the new standard deviation, because now I'm taking a sample, asking about the sample mean, right? You guys see that? So if I were you, well, it depends. If I'm you and I'm taking a test, I find the problem that I know I can do. Why do I do that? The same reason when you're starting to play a basketball game, the first thing you do is you go make some layups. Why do you do that? Build up a little confidence, right?
Yeah.
So in a test, you do the same thing. You're like, where's my layup? There it is. There's my layup. Do it. Build up some confidence, right? Now what sucks is if you take some layups and you miss them all, then you're like, no, but don't think about it. Don't think about it. Don't think about it. Then you step back to some 3-pointers. Maybe it's just going to be that kind of night. You never know. Yes?
Would we round that answer to a whole number?
Oh, no, because I can certainly have a decimal amount of trash, right? So, yeah. If I don't say what's around it to, normally a couple places is fine. Yeah, for like amount of trash or something, it's gonna be a couple places be fine.
That's the mean.
Okay. When in doubt, go 4 places, right? Because almost everything we do is 4 places, yeah.
Can we go over the homework for a sec?
Yes. What you got?
For 7.1, part 64.
Oh, okay. The one about the marathon runners?
Yes.
Okay. Which part is the question?
Well, I'm trying to so for part A, right?
Yep.
You have the mean would be approximately 49, right? You put.
No. So again, so in this problem, let's see, what can I catch real quick? Marathon runners average 145 minutes, standard deviation of 14 minutes. And we take a sample of 49 runners, right?
Oh.
Right, yes. 49 races, sorry. So then they ask you this question. The means follow what distribution?
I know in parentheses it's the mean, so 145 and then 14, but then.
No.
14 over the square root of 49.
Yes. I took a sample of 49, so what 2 things happen? What distribution does this become?
Normal.
Normal enough, so I'll put a normal here, right? Because it's greater than 30, right? So the means become normally distributed. What else happens?
Square root of that.
The standard deviation is not 14 anymore, right? That's for individuals. Now we're talking about groups of 49 and their averages, right? So this will be 145, and then 14 divided by square root of 49, which like people are saying is 2. Does that make sense?
Yeah.
I like it. So when I take bless you. When I take a sample, and I'm talking about the sample mean, if my sample size is big enough, it's going to be normal. And even if my sample's not big enough, my standard deviation changes. Okay. So if I gave you this problem, and you'll see why I won't. If I gave you this problem, okay, so I say, we have a mean of 111 and a standard deviation of 8.1, and I take a sample of 19 things. Can you figure out what the new standard deviation is?
Yeah.
Totally, right? What would it be? What would you do?
8.11 over square root of 19.
And you get a number, blah, 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 blah. If I ask you a probability question, can you do it? I love this question.
Yeah.
Why is the answer no?
Because you only took 19 for the sample.
Did I tell you how this was distributed?
No.
Does the sample size save my ass? If I don't tell you it's normally distributed, what saves my ass? If the sample size is bigger than, what is the sample size? So this would be something that in Stats 1 we could not do. This is an example problem I would not give you unless the question was just something like, would this be normal or something, right?
Is there any on the homework like that?
I don't think so.
Okay.
So say for 64, it doesn't tell us that it's a normal distribution.
But we know it is because sample size is
About 30.
more than 30. Yeah. So the nicer the distribution starts, the smaller the sample size could be. We had one where I took a sample size of 2 and it already looked pretty normal, right? Because it started off nice, started off as a uniform. You with me? But what the 30 does is even if your distribution is the most disgusting distribution you've ever seen, the minute you take more than 30 sample size, it becomes normal enough. Is it perfectly normal? No. Is it normal enough to use the chart? Go for it.
So anything over 30 is normal, anything below 30 would be,
Unknown. Could be normal, but we can't say. Because if they don't say anything about what it started off as, I need to see more than 30, or else I can't do shit.
so on the test, the sample size would always be above 30.
Has to be if it wants me to be able to do something, right? So I would never give you a problem where I have several questions and the answer would be can't do, can't do, can't do, because then people are going to be doing it and wasting time, and that would be so evil. Does that make sense?
Yeah.
I'm never going to give a problem where I'm like, look at all you doing the work and you didn't have to, it's just evil.
We'll never see like that up there.
Huh?
We'll never see that right there.
And again, if I gave you this, my point would be, my only question would be, why is this normal? Why or why not?
Oh,
I wouldn't ask you to do work. Do you see what I'm saying? Because that would be mean. If you didn't notice it's not normal, you're doing all this work and wasting time.
got it.
Okay. Whew. Yes.
So for 5, remember it's like the 2 z-scores and we got to find something too. It says the probability of 274
Yeah.
and 292.
Yeah.
Would that be around 20%?
Why? What was it, 292?
Yeah.
How do you know it's 20%? Just looking at it?
I think like, well I did, that's the answer I got.
Oh, what work did you do?
Well I did found the z-scores of like the 292.
Yeah.
Yeah, so and then the area for that was 6217.
Okay.
And
Yeah, so you find the areas below these two after you make them z-scores. Yeah, it sounds like you got the right work. I don't know if it's exactly the right answer. Again, it's up on campus, the answer key. Yeah. Sounds like you did the right work. Which again, I'm grading primarily for that. If you make a little mistake, like you get the wrong number off the z-score chart, or you do 2 plus 3 and you get 6, I'm pretty sure you don't believe that. You're not gonna lose as many, if any, points. I'm grading primarily on, do you know what to do when, right? So little mistakes, it depends on what they are exactly, but you normally won't lose that many points if you're doing the right steps. And if you show me work, right? The more work you show me, the more partial credit you could get in cases you need it. If you don't show me any work, you get the answer wrong, I have to assume the worst. You lose the most points. You are the weakest link. Okay. Anything else? Practice test, quiz, homework. You're all like, good Lord, I can't do any more.
Can you go to the second on the practice test, the second part, question B, or question 3?
Sure. What is that?
So the question is find the z-score with an area of 91%. Below it's
Oh, yeah.
But then the second part is find the z-scores bounding the middle of 91%.
Yeah, so here's the picture, right? The middle 91%, you with me? There's a picture that's the middle 91%. Does that make sense?
Yeah.
So the middle 91% would have the mean right in the middle, correct? The middle 91%. You with me? So what percentage is outside then? 91% in, 9% out. What percent's on that side?
4.5.
So it's 0.045 there, correct? Whatever that z-score is, whatever that z-score is, if that z-score is negative 1.8, that z-score is positive 1.8, symmetric. Boogie, woogie, woogie, right? Sorry. Every time I say the word symmetric, my brain goes boogie, woogie, woogie. So 0.045, I think it's 1.7, is that right? Or is that a different problem I'm thinking of? I can't remember. I think it's 7.0. Is the closest, I think. But, I could be wrong. I've been wrong before, and I'll be wrong again. Do you guys get that? The middle 91%. Does the chart understand this area at all? It doesn't have a clue about that area. It doesn't understand that area worth shit. It only understands areas below a z-score. How many z-scores do I need? 2. Can I get one of them if I know the area below it? Yes, because that's what the chart understands. So many of these problems are all about do you have the area in the right place, right? Because the chart only gives you and only understands areas below a z-score. Okay? So do you get negative 1.70? Do you guys see that?
Yeah.
And then, of course, that's going to be positive 1.70. It's got to be symmetric. You guys look really excited for this test. So again, it's all about just understanding. So there's two levels to mathematics: understanding a process, and the harder thing is understanding when to apply that process. I don't know if you guys agree with me. Hardest part about most mathematics is when to do what. You guys agree? Categorizing a problem so you know what to even attack it with, especially statistics. If you try to use a binomial probability where it's not binomial, you're never going to get the right answer, right? So you need to know, how do I identify if it's binomial? How do I identify if it's uniform? Well, that one's easy. It's only going to be uniform if I say it's uniform, correct? Do you guys, I don't know if that helped, but I just want to point out a couple things that confuse people. Anything else from anything? Okay. I brought nothing, by the way. I brought me. My openness to questions, so. Okay.
So for one, on C it says like find the mean and standard deviation.
Yes.
We already did in the part.
Totally.
And it says show your work. Like what if we just put?
Oh, yeah,
No,
can we
no,
just
no,
get
you
it from
can't.
there?
In the chart, you still have to show me, you know, and then you just pull the number out of the chart, right? Now this one, the standard deviation, you're gonna have to, here's the number you get from the chart, right there. You still have to show me that in the square root, right? Do you see what I'm saying? I want you to use the formula to give me the answer. This one I understand, you can just get it right from the chart, because that's all it is, the sum of that column, right? Maybe. So sometimes, if you just do this, if I have a x p of x, p of x, so you have your x times p of x, you got number, and the bottom you can just say mu equals the sum equals number. And on that problem you just put an arrow. There, Jeff, there, yeah, that's beautiful. That kicks ass. There it is. Thank you. Right? Standard deviation you can't just pull out of the chart because it gives you a part of it. Now I notice some of you guys do this. Do it, Jeff. You actually put this in the chart. That's fine. That's fine if you want to. You don't have to, right? Okay.
So then, what about 6A on the practice test?
Ah, what's it say?
So it says in the survey results.
Oh, yeah.
60% of
Okay. What kind of problem is? Can you guys see how to identify what kind of problem that is? So it could be uniform. It's not, because it doesn't say uniform. Does it give me a mean and a standard deviation? So it's not a normal problem, right? What's the other problem besides uniform and normal? Binomial. Is this binomial? Does it give me n? Does it give me a probability of success? Is there a probability of failure?
Oh, is that the C?
NPQ, it's NCR, yeah. So it's the choose dude. So I call those NPQ problems, because if I can see a total number, 24, right? And I can see a probability of success, 88% chance, right?
Yeah.
Yeah. So that automatically means there's a probability of failure, 12%. Don't think that way, right? There's a P, there's a Q, there's an N. Okay, that's an NPQ problem. I'm going to focus on those formulas on my formula sheet. Now again, I would never teach that, but then after you've gone through the concepts, you go, okay, what is it about the problem that's going to trigger to tell me which types of formulas to use? Does that make sense? Uniform, I have to use the word uniform. Normal, I have to give you a mean and a standard deviation, right? So if it doesn't give you either one of those, it almost has to be a binomial. Are you with me? And it's definitely not like an x p of x. They didn't give me a chart with x's and p of x's, right? Okay, maybe. So again, that's the problem with mathematics right there. It's the biggest problem is just, can you categorize the problem I gave you? If you can't, you're going to try to use the wrong thing. Does that make, and I know you guys have lived through this. I have lived through that so many times. Because it's just a part of making mistakes and realizing the mistake you made. By the way, if you're totally ready for the test, you can head out. Some of you guys are packed up and are like looking at me like, shut up, shut up. You can leave. You can leave, it's fine. If you still have questions, stay. Yes?
I do. Okay, see how this one put it's 0.91? That's technically my area, right? I just gotta find the C-score.
True. So we're looking at the second part of the problem. I said the middle 91%. So the chart only understands areas that are below a Z-score. So if there's 91% inside, there's 9% outside. Is that cool? If there's 91% in the house, there's 9% out. So how much is on that side? If there's 9% outside,
Yeah.
4.5. So if you look up 0.045, what's the closest you can get?
But that's why I get confused, because when I look at this, I'm thinking I gotta look for
But again,
91.
no. If you look up 91, it's going to give you the Z-score that's got 91% below it.
Okay.
So that's the first part of the question. What Z-score has 91% below it? This question says, what Z-scores bound the middle 91%?
Oh, so then we gotta look at the outside.
So 0.91 has nothing to do with the chart. The chart would not understand this at all. It only understands areas below. So what areas below that's, I want both of these Z-scores, correct? So what areas below this one? 4.5%.
The keyword is middle, I guess.
Yes.
Okay.
It bounds the middle 91%. So the chart would not understand 91% at all. It only understands areas that are below.
Okay.
Okay. So let's do, real quick. Let me see. Watch this, guys. Can you help me? Normal curve, right? Normal distribution. And I want to know what's the Z-score that has 5% below it. Just that. It's not this yet. It's just that. Can you guys find the Z-score that has 5% below it?
Yeah.
It's the 1.645.
Yeah, negative, right?
Yeah.
Can everybody see that? Can everybody do that problem? If I gave you that problem, that's a nice problem, right? Do you agree?
Is that D on what?
No, it's just me making shit up. Okay. Which is what D was, but not specifically that. Now, look at this same result. I want the two Z-scores that bound the middle, what, Jeff? I don't know. 90%. Can you draw that? I want them to bound the middle 90%. So I want them to chop it with 90% in the middle. Can you draw that? So I want this Z-score and this Z-score. This Z-score, so how much is outside then? The 90% inside, 10% outside, 5% there. Do you see how I've made it into exactly this problem? Same problem. Same answer. And what's that going to be? Because of symmetry. Is that better?
Yeah.
So if you realize the middle thing turns into a problem like this, and you guys can eat this problem up, you have to be able to eat that problem up. Same thing. Thank you. Okay, maybe. By the way, I forgot to say, I'm not sure how to say this, the last quiz, you guys outperformed my other stats class. Now, the reason I'm saying that is because everything else you've gone a little under in terms of mean, but the last quiz you blew them out of the water. So I'm a little worried about them in terms of what happened with the last stuff. But just to let you know, you're catching up. Yes. Totally. Yeah, I was giving them out.
I don't know.
Who didn't get theirs back? So if you came in after I gave them out, I'm sorry, you gotta always come up and see me. No, what's your name? Carla. What? Those are the, yes. That's the formula sheet, yeah, I'm sorry. Yeah, that's it, gotcha.
It's good.
What about? So the min and max are 2 steps away.
Minus
Yes.
2 plus 2.
Minus 2 standard deviations plus 2 standard deviations, yep.
Okay. Yes, sir.
Yeah, and now that you know the max and min usual, 16, is it in between those?
24.
So it's between, is it between those? No, it's below the minimum, so it's unusually low. So usual, so that it's a minimum usual and a maximum usual. Anything outside of there is unusual, because it's not in the expected area, it's not in the usual area.
Yeah, this one right here,
Is that, really weird, right?
Here, 16. Here,
Wait a minute.
24.
Oh, so again, so that's the problem where you have to put the mean in the middle, go down 1 step, and go up 1 step, and then see what percentage of the data you caught, right? So if you got 4.253, right, whatever it was, and this will be 0.0 something,
So you populate.
sure, 0.0005, if you gotta go up now, so that'll be like 8.5 something or other. So which data points did you catch? Did you catch -1, is it in here? It's down here, isn't it? Did you catch the 3s? Yep, did you catch the 6s? Yep, did you catch the 11s?
Pass rate test correction.
12, no. So what percentage of your data was 3s? Plus, what percentage of your data was 6s?
أنا بشتغل في التوتري
194? Add those as the answer.
بس قالوا لي
You cut all the 3s, that's 35% of the data, you cut all the 6s.
فلو عايز أي حاجة
So what's the total you caught?
أصحابك
Add. And again, it's only answer. Right.
بس اطلبي اسمي روحي العربي روحي الانجليزي اطلبي اسمي
Anybody else not figuring? Anybody else not get their quiz back? Everybody got their quiz?
من مصر
احنا لسه ما بنثق قديش في الاسبوع.
انبسطت